In this last section of notes, we're going to look at an application of law of cosines, so applying it to a life situation, and we're going to see how to find the area of some of these triangles when they don't just have a nice and even perpendicular base times height that you can do. These area formulas are on your reference sheet, so just so you can see them for reference, you're going to be doing 1/2 times 2 of the sides, and then it's going to be sine of the angle in between those sides. So it's going to be all three letters getting used no matter which of the formulas you're utilizing. So here's an example. You can see that we have angle A, side B, and side C. So in this case, to find the area, we're going to be using this top one since it's the angle A situation. All we really need to do is multiply the four things together, the 1/2, the side, and sine of the angle. So when I'm computing this, we have 1/2 times 14 times 21, and then make sure your calculator is in degree mode, times sine of 52 degrees. Now the order you multiply these things in will not matter. So for example, you can do things like 1/2 of 14 is 7, and then just do 7 times 21, and then multiply that by sine of 52 degrees, and you should get approximately 116 if we're running it to the nearest square meter. So that is the area. That's all you need to do for those. Just follow the formula on your reference sheet and make sure you're picking the right one in regards to which angles and sides are being shown. Here we have a complicated diagram showing different triangles drawn in there from the first base to the pitcher's mound. They give you some of the basic information here, like the bases are 90 feet apart, so you can see that length shown here along the side of the diagram. And the front of the pitcher's rubber is 60.5 feet from the back corner of home plate. So they have that side filled in for you as well, that it's 60.5 going all the way to the back of home plate. What they want us to find is the distance from the center of the front of the pitcher's rubber to the far corner of first base. So basically we just need to find this third missing side of a triangle. Now they've given us that this is a 45-degree angle in here, and they've told us two of the sides of the triangle. So we should be able to use law of cosines to find the missing side C in this case. Now they already had all the sides and angles labeled for us in the diagram, but sometimes you might have to do that labeling yourself, and just make sure you're very careful about specifying the angles and the sides being the ones opposite each other. So in this case, we want to find side C, so we're going to be using this formula here. So we're going to have a squared, b squared, 2ab, and cosine of c. So for our example, c squared equals 60.5 squared plus 90 squared minus 2 times 60.5 times 90 times cosine of 45 degrees. So all of this can just be plugged into your calculator at this point, and the value I'm getting from it is 4,059.857. Now again, I'm not just going to round off my decimal a certain number of places. What I actually want to do is take the square root of both sides of the equation. So when I'm doing that, I want to make sure that I'm entering the square root of the previous answer in my calculator, rather than just trying to round off some number of decimal places. And by doing that, I'm getting 63.7, and it looks like the example seems to just be having it round to one decimal place. Since they didn't specify anything like to the second or the first decimal place, I'm just going to keep consistent with the smallest decimal I see for theirs. So 63.7 should be sufficient. If you were very careful, you might have remembered that taking the square root of both sides of an equation gives you a positive and negative answer. But in this case, it doesn't make sense to have a negative length. The negative in these kinds of problems usually just indicates direction. So all we actually care about is that there's a 63.7-foot distance from first base all the way over to the center of the pitcher's mound. And that's it for the notes. Thank you.